first off, we've been working with long division, synthetic division, and when we were dividing, what conclusion did the remainder help us make? If you're remembering with me correctly, if we got a remainder of 0, that would tell us that our divisor was a factor of the polynomial we were dividing. If we got anything other than 0, then we knew that that divisor was not a factor. So the long division, synthetic division, that's a great way of being able to figure out if it's a factor or not. But sometimes we wonder, is there an easier way? And that's going to get into what we're learning today. We're going to learn about the remainder theorem. Basically, this is a quick way for us to figure out what the remainder is. And we can use that to help determine if we're getting a, we're going to use that to help us to determine if our divisor is a factor, but then it also helps us know if certain values are roots, which is another word of saying x-intercepts for the polynomial, which will be helpful when we get to graphing and doing other things. So that's what we're going to go over today, is how to use the remainder theorem. So here's what the remainder theorem tells us. If a polynomial f of x is divided by a binomial x minus k, and k means any number, then the remainder of this, in the quotient, the remainder is going to be the same as if we just plug in k. So what that's saying is that instead of going through the whole process of long division or synthetic division, if all I'm interested in is the remainder, then if I just plug in the value in our divisor, that turns this to 0, that's what k is, then that will tell me what the remainder is. And if I get 0, well, what does that tell us? This is actually the factor theorem. A polynomial function f of x has a factor of x minus k if and only if f of k equals 0. If we get 0, it tells us that x minus k is a factor. So this is going to be our steps we're going to do with the remainder theorem. Step 1, find the 0 of the divisor. I'm looking at my divisor and saying, what makes that become 0? Then I'm going to substitute that 0 into the dividend. We're going to plug it in, evaluate it, and see what value it gives us. If we get 0, it tells us the divisor is a factor. It gives us anything other than 0. It tells us the divisor is not a factor. So let's see how that works here, okay? Here's my polynomial. It's being divided by n minus 7. So my first step is to think, what turns that into 0? And that would be 7. That's going to be what I'm going to plug in for n anywhere here. So I'm going to actually rewrite it here. I'm going to do 2 times 7 to the third minus 13 times 7 squared minus 17 times 7 plus 70. This is a little above my mental math skills, so that's when I get my calculator. And I'm going to plug it in, and if you want to practice plugging it in so we can check our work to see if we get the same answer, it's a great idea. And when I do this, I got 0. Awesome. So when I plugged it in, it gave me 0. What that tells me is two things. Number one, it tells me that n minus 7 is a factor of this polynomial, meaning it divides evenly into it. Now, it didn't tell me what the quotient would be. I'd have to do long division or synthetic division to get that, but I do know it's a factor. The other thing is that when I graph this polynomial, 7 is a root for it, which is another way of saying that it's an x-intercept. We'll talk more about roots in the next section as well, but for now, that's the conclusion we're going to make. So let's do a couple other examples so we're more familiar with this. Let's go to this next one. Here's our polynomial, and we are going to divide it by n minus 5. That means, what would turn that to 0? What are we working with here? And it would be 5. So 5 is what we're going to plug in. Everywhere I see an n here, I'm going to put a 5. So then I get out my calculator. Again, I would encourage you to try this on your own, or if you're using your phone or you're using Desmos, whatever you're using, see if you get the same thing that I get here, because it's very common for people to make a mistake when plugging things in. when I got this, I got a remainder of 3. Now, anything besides 0 lets us make a conclusion that this is not a factor of this polynomial. So I'm going to put a little note, it's not a factor. Which that also tells me that 5 is not an x-intercept. Okay, you getting the idea? Hopefully this is starting to make sense. Now, before we start doing this third example here, I want you to look at it and tell me what's different about this divisor. We've done 2 examples now. Well, what would turn that into 0? And the answer is negative 10. All these other ones, we've got a positive number. This one, it's negative because what number, if I add 10 to it, gives me 0, it's going to be negative 10. This is where you have to be really careful. When I'm looking with a negative, depending on the exponent, it will simplify that negative to a positive or it won't. So you have to be very careful. So with your parentheses here, so I'll try to do this. I'm going to do negative 10, and the whole thing is raised to the third. Make sure you put that in parentheses. And I've got negative 10 squared, 65 times negative 10 plus 50. So last time for this page, I'm going to plug that in with my parentheses in there. And when I did, I got 0. Awesome. So the question is, what conclusion can I make about x plus 10 and negative 10 now that I know the remainder is 0 when I plugged in negative 10? And I can say that x plus 10 is a factor of this polynomial. We call that the dividend. It's a factor of the dividend. And negative 10, if I were to graph this polynomial, it's an x-intercept. So those are the conclusions that we can make from this. Now let me show you one other type of example we're going to use here. On this one, we're given one polynomial, and we're given 3 different divisors. And we're asked, basically, what are the following factors? Do they divide in evenly? And the question is, on this, it's not asking for the quotient, it just wants to know, does it divide in evenly? Well, the way we can check that is by plugging in whatever turns that to 0, and hoping we get a remainder of 0, because if that works, then we know it divides in evenly, and it's a factor. So let's go through this now. What would turn x plus 1 to be 0? It's negative 1. So I'm going to plug in negative 1 here. Again, when I plug in a negative, I have to be super careful with the parentheses. So I'm going to show you how I'm going to put that into my calculator to make sure I don't make a mistake. Now, this is one we could probably do mentally, so I'm actually not going to use my calculator here. The other ones were giving us pretty big numbers. But negative 1 cubed is still negative 1. Because negative times a negative times a negative is still a negative. Negative 1 squared is a positive, but we're timesing it by a negative, so that's negative 2. Negative 5 times negative 1, that's a positive 5. And then we have positive 6. And it's not looking so good here. Because if I look at the negatives, that's negative 3 plus 11, which is 8. What is our conclusion? If our remainder is anything but 0, it's telling us that is not a factor. I'm just going to put big red X here to say, nope, that did not work out. Okay, so let's go to the next one. Try it out. This one, what makes it 0? It's negative 2. We're going to do this same thing now. Plug in negative 2. Since it's negative, I'm going to be super careful with my parentheses. And I think this is one that we could still do without a calculator. So I'm going to do negative 2 cubed. That's negative 2 times negative 2 times negative 2. That's negative 8. Negative 2 squared is 4, but then I'm going to times the 4 by negative 2, and that's negative 8 again. Negative 5 times negative 2 is a positive 10, and then plus 6. So now, if I combine the negatives, I get negative 16. And if I combine the positives, positives, I get positive 16, that gives me 0, and so that tells me, yes, we can say x minus 2 is a factor of f of x. It's good to specify that it's a factor of f of x, because x plus 1 might not divide evenly into here, but it might divide evenly into something else. Just because 3 is not a factor of 7 doesn't mean 3 can't be a factor of 9. So we're specifying what it is or is not a factor of. It also tells us if we graph f of x, that negative 2 would be an x-intercept. All right, last one here. We're going to look at positive 3. That's what would turn that to be 0. And when I plug in a positive 3, let's hope we don't run out of room here. I've got 3 cubed minus 2 times 3 squared minus 5 times 3 plus 6. 3 cubed is 27. 3 squared is 9, but we're timesing that by negative 2. That's negative 18 minus 15 plus 6. So 27 plus 6, that's going to be 33. Negative 18 minus 15, that's going to be a negative 33. So that's going to give us 0. So this will mean that x minus 3 is a factor. So I'm going to say for both of these, they are factors, they are x-intercepts. And that is how you